And welcome back to our course in trigonometry. In this video, I wanted to discuss special triangles. Okay, so the key ideas that I need you to take away from this video are the 45-45-90 triangle and the 30-60-90 triangle. Okay, now when I say 45-45-90 triangle, I'm sure you know this already, but I am talking about the angles in my right triangle. Okay, so we remember from our high school geometry that if I add up all the angles in a triangle, if I add up the measure of all the angles, I'm going to get 180 degrees. So that means if this one is already 90 degrees, then these two other angles must add up to 90 degrees. In other words, these two angles must be complementary. So one possibility is that each of these guys is 45 degrees. Now, it's not hard to believe that if these two angles are equal, then the sides that they open up onto must also be equal. Right? If this angle opened up wider, then this side would have to be taller compared to the other side. Okay, so if these two angles are equal, then they must open up on equal sides. So whatever this length is, this is also the same length. Okay, now the question is, what is the length of the hypotenuse? And we've got the Pythagorean Theorem to help us figure it out. So if we know this, and we know this, then we can figure out C, whatever that is. And we know that the square on each leg added together should give us the square of the length of the hypotenuse. Okay, well, using our algebra, right, we got like terms here. We got the same variable and the same exponent. Okay, so this is telling us that c squared is equal to double x squared. Now, of course, this isn't telling us c just yet, it's telling us c squared. We've got to work backwards. We've got to use the square root. Now, go back to our last video on the Pythagorean Theorem where we discussed how to simplify square roots like this. Okay, the square root of a product is equal to the product of the square roots. Okay, so this is equal to square root of 2 times the square root of x squared. So, in other words, square root of 2 times x. So we have special case here of the Pythagorean Theorem. Now, in the Pythagorean Theorem, we noticed that if we knew any two of the side lengths, we could always figure out the third side length. With this special triangle, with the 45-45-90 triangle, I only need to tell you one of the side lengths. If I told you this is 5, let's say 5 centimeters. Well, if it's a 45-45-90 triangle, this side also has to be 5 centimeters. And this one has to be 5 radical 2 centimeters. Okay, whatever that is. We could get an approximation using a calculator if we needed it, but we'll just call it 5 radical 2. So with this special triangle, if you know just one side length, you can get the remaining two. Okay? The 30-60-90 triangle is somewhat similar. So let's imagine, for right now, an equilateral triangle. Okay, all the sides are the same length. Okay, so whatever this side length is, this is the same, and so is this. Now, if all the sides are equal, that must mean the angles are equal. Remember the line of reasoning that we used over here. These two angles being equal meant that the sides they opened up on had to be equal. Well, here, this angle is opening up on a side that is the same length as this one, that is the same length as this one, so all the angles must be equal. So in other words, all the angles must be 60 degrees. Now, I can't quite use the Pythagorean theorem yet. The Pythagorean theorem applies to right triangles, in other words, a triangle that has a 90-degree angle involved in it. This is not a right triangle. But what we can do is we can drop a perpendicular down from that peak right there. So it's actually two 90-degree angles. In fact, let's go consider this, the side length of the original. I initially had it x. It's going to make things easier if it's 2x. We'll see why in just a sec, because I'm cutting this in half, okay? So let me take one of these angles here, one of these triangles. Okay, so I'm going to take that and I'm going to put it over here. Okay, so here's that right triangle I just made. Okay, I'm going to take this angle, put it up here. So that's my 60-degree angle. I cut this thing in half, so I cut that angle in half, so that must be a 30-degree angle. Right now, this side became the hypotenuse of my right triangle. That's 2x. I cut the bottom side in half, so that's now x. Okay, that's the reason it's easier to have it double all the way around. Okay, so that's x. Now the question is, what is this? Okay, let's call that b for right now. Okay, well we got the Pythagorean theorem, so we know that this squared plus this squared is equal to the square of the length of the hypotenuse. So x squared plus b squared equals 2x squared. Notice I put parentheses there, okay? This means I got to take the whole quantity 2x and multiply that times itself. 2x times 2x actually gives me 4x squared. Okay, so if this equation is true, that means x squared plus b squared equals 4x squared. And that means b squared equals 3x squared. And finally, radical 3x. Okay, so here I'm squaring my 2x as I explained, 2x times itself. Here I'm getting b squared by itself on the left side of this equation. I don't want the x squared anymore, I got to subtract it away. I had 4x squared on the right hand side. If I have 4 of those and I take away one copy of x squared, that leaves me with 3x squared. And now we got to remember that we have solved for b squared. We got to go take square roots to get b. All right, and we're remembering that the square root of a product is the product of the square roots. So I can take the square root of each one individually. The reason that helps is because the square root of x squared is x. In this case, x is a positive number because it represents a length. Okay, so the square root of x squared is x. So that part simplifies, and this is radical 3 times x. So, once again, another case where if we know one of the side lengths, then we can figure out the remaining two side lengths. So if we know we have a 30, 60, 90 triangle, if we are given this side length, then we double it to get the hypotenuse. And then whatever we had here, we multiply it by radical 3 to get the other leg. Okay, let's do a quick example here of using these special triangles to help us out. Okay, so let's do this example here. an escalator will make a 30-degree angle with the horizontal. The escalator needs to reach a height of, let's make it 15 feet. How long is the escalator? Question mark. Okay, so escalator is going to make an angle of 30 degrees with the horizontal. We need to reach a height of 15 feet. How long does the escalator need to be? So this is the schematic that we're looking at right here. Okay, this hypotenuse, that represents the escalator. This angle is 30 degrees. This angle is 90 degrees, because that's the floor. This is the height we need to go up to. So those two are perpendicular. They make a 90-degree angle. Since these two angles have to be complementary, that means we got a 60-degree angle right there, 30, 60, 90 triangle. Now we are told that the escalator needs to reach a height of 15 feet. So that means that this side length in my special 30, 60, 90 triangle must be 15 feet. Now, think about the scheme that we had before. Okay, we got this situation. Now remember, whatever this was, the hypotenuse was double that. And we also knew this, that this leg was radical 3 times that height. So, gosh, my escalator is a little curved there. I'll feel better if I draw it nice and straight. Okay, so if this is a 15, I got to take that length and double it. Okay, so if the escalator has to reach a height of 15 feet and it's making an angle of 30 degrees with the horizontal, then the escalator itself has got to be 30 feet long. So a nice use of a special triangle. Okay, so we got a couple of things in our course so far involving triangles. First, Pythagorean Theorem. That gives us a relationship that the side lengths of a right triangle have to fit into. So if you know any two of the sides in a right triangle, you can always figure out the third. Now these special triangles give us a shortcut in certain cases. And if you are dealing with one of the special triangles, either a 45-45-90 triangle or a 30-60-90 triangle, then you only need one of the side lengths. And then you can figure out the other two using the relationships between the side lengths. In fact, I kind of like to remember them this way. In your 45-45-90 triangle, okay, I know when I was doing the demonstration, when I was doing the explanation, I made that an X. But just think of it as a 1. Whatever that is, this has to be the same, and this is radical 2 times whatever length. So if you need to scale this up, just multiply all the sides by that same scale factor. So if this is a 3, hit this with a 3, hit this with a 3. In your 30-60-90 triangle, same thing. We're going to make the short side equal to a 1. So the hypotenuse is double the short side, and the other leg is radical 3 times the short side. The way I remember this is the radical 3 that goes next to the 30, right? The 30 has a 3, the radical 3 is adjacent to that angle. Okay, so two very useful triangles. For our course in trigonometry, I would recommend committing these to memory. They are going to come up repeatedly throughout the course. So commit these two triangles to memory for the duration of this course, your two special triangles.